Hello, welcome to my channel. In this tutorial I'm going to explain image filtering example with Scipy functions. Image filtering is a technique used to enhance or manipulate images. By using these techniques, we can modify, enhance, blur, and extract valuable information from images. They are fundamental tools that enable us to improve image quality, detect important image characteristics, and others. Filters can be used for a variety of tasks, including noise reduction, edge detection, feature extraction and enhancement, smoothing and blurring, and picture alteration and restoration. In this tutorial, I'll briefly explain some of the filtering methods available in Scipy library. Here we'll go through the Gaussian, median, maximum, minimum, Sobel, Laplacian, and custom filters. We'll start explanation of the Gaussian filtering. Gaussian filtering is a popular smoothing technique that reduces noise and blurs the image. It applies a Gaussian distributed Bayesian convolution kernel to each pixel, which gives more weight to nearby pixels. The sigma parameter here controls the amounts of blurring. In Scipy, there is a Gaussian filter function, so we can easily apply this filter by using Gaussian filter function. Next is median filtering. Median filtering is a non-linear filtering method that effectively removes noises from the image. It replaces each pixel's value with the median value of its neighboring pixel within a specified window size. Here, a size parameter determines the size of the neighborhood window. So a median filter provides median filter implementation. Maximum filtering enhances bright regions and highlights prominent features in an image. It replaces each pixel's value with the maximum value of its neighboring pixel within a specified window size. Here is size neighboring window size. We can use maximum filter to apply maximum filter to an image. Minimum filtering enhances dark regions and suppresses noise in an image. It replaces each pixel's value with the minimum value of its neighboring pixel within a specified window size. Here a size parameter determines the size of neighborhood window. In Scipy, we use minimum filter function to apply this filter. Sobel filter is a common technique for edge detection in an image. It applies separate convolutions to the image with two small gradient filters, one for horizontal edges and one for vertical edges. The resulting edge image highlights regions with rapid intensity changes, representing edges in original image. There is a Sobel function, so we can easily use this function to apply Sobel filter to detect edges in an image. Next is a Laplacian filter. It's another method for edge detection. It calculates the second derivative of the image to detect regions of rapid intensity changes, which correspond to edges. The resulting edge image can be more sensitive to noise compared to the Sobel filter. So Laplacian function provides Laplacian filter. So you can use this function to implement Laplacian filter to an image. Custom filter or convolution. We can also implement custom filters to an image. So first we define a kernel or kernel and we convolve this kernel to an image. You can design a kernel to perform specific operations like sharpening, blurring, or extracting features. The convolve function applies the kernel to each pixel, combining their values based on convolution operations. In this code, we define the kernel and then we apply convolution with defined kernel. So the we can apply that kind of the filters too. Now we can apply all of the above filtering methods to the image and display the output in a graph. First, we load all required libraries for this tutorial. We use Matplotlib library and the Scipy, NumPy, and Pill libraries. We load the image file here, and then we convert to grayscale and apply all the filters one by one. Finally, we collect all outputs to the list and display in a graph. So output looks like this. So original, Gaussian, median, maximum, minimum, Sobel, Laplacian, custom. That's it for this tutorial. You can apply those filters to your image processing tasks and use the right one for your tests. Thank you very much for watching, and please subscribe and hit some button